Now that we have defined the congruency of two figures, now let's see how we can connect congruency with areas. Two figures are said to be congruent if they have same shape and same size. Then what will be the status of their areas is what we are going to define in today's session. Congruency connected with areas. Now that we have defined congruency, let's recall the definition. Congruency is connected with same size and same shape. Now it is generally assumed that if two objects or two figures are of same size and same shape, mathematically it is proved that they must be of the same area. So here comes the conclusion that if two figures are of same size and same shape, then mathematically they must have the same area. That is, the measure of their planar region or the magnitude of their planar region must be same. Is how we define the property. Therefore, when two figures are congruent, not only did they have same size and same shape, they have same area. So I come to the conclusion that two congruent figures have same area is how I conclude the statement. Two congruent figures have same area is the learning outcome, and congruency connected with areas. Now that we have connected areas with congruency, let's come with the converse of connecting congruency with areas in a similar manner. So what does the converse say? The converse is about if the two areas are equal, will the two figures be congruent? Because in the previous session we have seen that if the two figures are congruent, then their areas must be equal. Now the question comes, if the areas are equal, will the two figures be congruent? Let's investigate the congruency of two figures connected with areas. As converse. So my question here is, if the two figures have equal areas, then will the two figures be congruent is the biggest question out here. So let's investigate this. If the two figures have equal areas, then will the two figures be congruent? So imagine I take a triangle whose area is say 12 centimeters square. And imagine I have a parallelogram whose area out here is also 12 centimeters square. Now clearly we know that the area of the triangle is 12 centimeters square and area of the parallelogram is 12 centimeters square, and therefore the areas are equal. So I find the areas to be equal for both the triangle and the parallelogram. But are they congruent? Let's see if triangle is congruent to parallelogram. The congruency concept says that the two figures are congruent if they have same shape and same size. Now here comes the question on the triangle and parallelogram have same size because their areas are same, but are they of the same shape is also very important in ruling out for the congruency. In justifying the two figures to be congruent, we have to justify on same size. Yes, of course, they are of same size, each size being 12 centimeters square, but are they of the same shape? No, this is a three-sided figure and this is a four-sided closed figure, so they're not of the same shape. It fails with the second case. This is a three-sided figure and this is a four-sided figure. Therefore, they are not of same shape, but they are of same size. Therefore, I come to the conclusion that if the two figures have equal areas, as in the case of triangle and parallelogram, then the two figures may not be congruent. Not always. They are congruent if it satisfies with the condition that the two figures have the same shape. Failing with the condition here, three-sided and four-sided figures can never be of the same shape. Therefore, my learning outcome or the conclusion out here is that two figures with equal areas need not be congruent. Congruent is how I conclude two figures with equal areas need not be congruent. Is the conclusion in the converse. So the converse of the congruency statement says that two figures which have equal area need not be always congruent, just in the case of triangle and parallelogram.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.